The lymph node is a completely encapsulated structure embedded between lymphatic vessels. They are found in many areas, such as in the inguinal region, the patella, the axilla, the chest, the abdomen, and so on. When examining the lymph node, we can distinguish the following. Externally, we can see the capsule surrounding the lymph node. From the capsule, column-like processes known as trabeculae extend into the parenchyma. Underneath this capsule, there are three main layers: the cortex, the paracortex, and the medulla, each with their own cells and functions. Starting with the cortex, it is the outermost layer of the lymph node, which sits directly under the capsule. The first thing you may notice are these dots spread throughout the parenchyma, giving it a poppy seed-like appearance. These are the body's immune cells or lymphocytes. The cortex contains lymphoid follicles, which are small clusters of B lymphocytes found in various lymphatic organs. These lymphocytes are always found in a follicular arrangement. Within these follicles, antigen-presenting cells present collected antigens to the naive B lymphocytes, thus activating them, causing them to differentiate into plasma cells. The plasma cells then produce antibodies against these antigens. Lymphoid follicles can be either primary or secondary. Primary follicles are darker with inactivated B cells which have had no recent exposure to antigens, while secondary follicles have an outer mantle zone made up of resting B cells and a germinal center, which is lighter in staining due to the presence of larger, actively dividing B cells. The next structure within the lymph node is the paracortex. It is located beneath the cortex. The main difference is that it contains T lymphocytes in a diffuse arrangement rather than a follicular arrangement. Similarly to the cortex, antigen-presenting cells will present antigens to these naive T lymphocytes, activating them and causing them to directly attack the pathogen. It also contains high endothelial venules, which are modified vessels responsible for bringing B and T lymphocytes to the lymph node from the blood. Lastly, the innermost part of the lymph node is the medulla. It consists of a network of medullary sinuses which carry the lymph towards the efferent lymphatic vessels. It also contains medullary cords, which are found between the medullary sinuses, and they contain plasma cells and lymphocytes. The medulla is the site of antibody production from plasma cells. The flow of lymph is also very important, and it is carried out by sinuses inside the lymph node. The afferent lymphatic vessel brings lymph to the lymph node. It then flows to the subcapsular sinuses, beneath the capsule, to the intermediary sinuses, then to the medullary sinuses, and finally to the efferent lymphatic vessel. So now we can understand that the function of the lymph nodes is to filter the lymph before it returns back to the blood through the lymphatic ducts. They are also necessary structures for immune responses since they contain B and T lymphocytes, and it's the site for cellular and humoral immune responses.